Okay, students, let's get into the explain problems. We're going to be working on problem number 1 from the worksheet. And I got here the heights and the names from group 1. And the first step is getting our set, which we called n, and we have to get the number of elements in that set to find the mean and the standard deviation. So can anyone please tell me how many elements are in n?
Yes.
Yes, please.
It's 7.
There you go. Thank you. So now what is the next step? Finding the actual mean. And the formula for the mean is the summation of all the elements in our set from 1 all the way to n, which is the number of elements in that set. So let's get started. If it's the summation, what will be the first number to write here? Ivan?
64.
There you go. And then plus 65, plus 67, plus 68, plus 69, plus 71, plus 71. And don't forget to divide all that by your n, which I actually forgot, but it's by your n, which in this case is equal to 7. So all this divided by 7. And our mean would be, any volunteers? Yes.
67.71.
There we go. 67.71 is our mean. I'll just give you a couple of minutes to write that down. Now that we have our mean, we can solve our standard deviation, which is this symbol, or you can use the S. And the formula for that is the square root of the summation of all the x's minus the mean, where I is equal to 1 all the way to n, which is the total number of elements, all over n minus 1. Any questions? So we have our huge radical right here. And we begin. The first number is 64, so it'll be 64 minus our mean, 67.71. Oh, sorry, squared. So it'll be squared plus 65 minus 67.71 squared plus 67 minus 67.71 squared plus the next number will be 68. 68 minus 67.71 squared, and then I'm going to keep going here in the bottom, plus 69 minus 67.71 squared plus 71 minus 67.71 squared plus 71 minus 67.71 squared. All over n. N was again?
N minus 1.
N. The number of elements right here.
It's 7.
There we go. Thank you. And then will be 7 minus 1, which is equal to 6. I'll give you a moment to work it out in your calculator. Luis.
Is it 2.74?
Yes, very good. Now, before we continue, I want to go back to the actual problem. Remember that it's the square root of all of this divided by n minus 1. And remember, here is the square. I know I forgot it here, but now you know every element on our set minus the mean is squared. And then you find the average of this minus 1 element, which is 6. And our answer is 2.74.
Hello, for the elaborate part of this section, we're going to be looking at a data margin for the male Spanish origin workers and the non-Spanish origin workers in the year 1978. So here students will be able to see different patterns, right? For example, on the Spanish origin margin, we can see that an annual wage was $13,478, while on the non-Spanish origin wage of an annual is $17,483. So there we can obviously see that there's a decrease in margin here as there's an increased margin in here. So what the students are able to do is use the mean, the average, for this data margin. Now how do we find the mean? It's the sum over the count, and that gives us our answer. So first we do the Spanish origin mean for the male workers, which is the sum, which is 105,498 over the count 14, which gives us $7,535. We'll do the same thing for the not Spanish origin workers. The mean for that will be the sum, which is $147,371 divided by the count, which is 14, which gives us $10,526. Now here we can actually see the difference when we subtract the two values. We see that the difference is $2,991. So we see that there is a difference in between this data margin for the male Spanish origin workers and the not Spanish origin workers. And the standard deviation for the Spanish origin workers is 8,357, while for the not Spanish origin workers is $11,521. So here students are able to use their skills in mean and standard deviation to make conclusions and see patterns and differences. Similarly, if we go over here with the female side, we'll do the exact same thing relating to the annual income of 1978. So here we'll look at the first data margin, which is Spanish origin. Here are the values. For not Spanish origin, here are the other values. So now, if you notice here, it's kind of more difficult for the students to see patterns. But nonetheless, that's okay. We can still despise use the mean. So for the mean for the Spanish origin workers is again the sum over the count, which is 28,847 over 14, which is $2,060. Similarly, we do it for the not Spanish workers. Again, it's the sum over the count, which is 59,678 over 14, which gives us $4,262. Now, again, we do see a difference on the Spanish origin female workers and the not Spanish origin female workers. The difference is $2,202.21, with the standard deviation being 4,329 for the not Spanish origin workers. So here students are able to use their skills in standard deviation and mean to see differences and patterns. Here we're using a real world situation. Female Spanish origin workers and not Spanish female origin workers, as well for the male. And in conclusion, as you can see, we covered two important topics. Not only was immigration and factoring wages, but as you can see, gender also played an important role. We saw the differences in Spanish origin and not Spanish origin male workers and female Spanish origin and not Spanish origin workers. Following, they will observe their data and use their skills from mean and standard deviation in order to see these kinds of differences, while still maintaining a culturally relevant mindset on immigration and gender.